Hello students, today we are starting with the next chapter of the 10th standard, that is calorimetry. If you like the video, please do subscribe my channel Tello Open Academy. We are starting with the chapter calorimetry. Calorimetry word is made up of two separate words, calorie plus metry. Calorie means unit of the heat energy, metry means measurement. This means heat measurement. So calorimetry is the branch of physics which deal with the heat energy measurement and its techniques and the various principles with which we can measure the heat energy lost by a body or gained by a body. Before we go into the main portion of the chapter, few of the basics which will help us to grasp the important concept of the chapter. First concept of the heat energy. We know that all the substances are made up of atoms or molecules. Molecules of a substance, they are continuously in the state of random motion and they possess kinetic energy. If we are talking about liquid or the gas, they can move in any direction and they possess kinetic energy. And if we are talking about solids, then solid atoms or molecules, they cannot move, but they can do vibrate about their mean position, and then they will possess kinetic energy of a vibration. Other than this, the molecules or atoms, they also do exert attractive forces on each other, and due to these attractive forces they possess potential energy. So there must be some force which is binding all the atoms or the molecules making up the given substance, and due to that attractive force, which is called intermolecular force of attraction in case of molecules or interatomic force of attraction in case of atoms, which give rise to the another type of energy which they possess, which is called potential energy. Thus all the atoms or the molecules in any substance, they possess these two types of the energies: kinetic energy arising due to the state of the motion, and potential energy arising due to the attractive force existing among atoms or the molecules. So if we add the kinetic energy and potential energy of all the molecules, we call this as the internal energy of the substance, and this internal energy is nothing which what we call in general as a heat energy. So this energy, because it is present inside the body, inside the substance, in the form of kinetic and potential energy of the molecules, that's why it is called as internal energy, and this internal energy is alternatively known as the heat energy. If we are talking about hot bodies, the hot bodies have more amount of internal energy, but cold bodies have lesser amount of internal energy. If you remember a small experiment in your lower class, where if we have a solid metal rod and if we hold it from one end which is colder and another end which we put it in a flame, then after some time there will be a transfer of the heat energy from the hot end towards the cold end, so that it will become difficult for us to hold that metal rod. Here the transfer of the heat energy from the hot end towards the cold end, it takes place due to the molecular vibrations, and due to these molecular vibrations there is a transfer of energy, heat energy or internal energy from hot end towards the cold end. So this simple activity or this simple experiment indicates that whenever we heat up any object or a body, then its molecules, they increase their random motion, and due to that random motion kinetic energy increases, and due to increase in kinetic energy the bodies become hot, so that their temperature rises. But if we have a cold body means we are extracting or making the energy to come out of the body. When energy is lost by a body, then their random motion, speed of the motion decreases, kinetic energy decreases, hence their temperature also decreases. That's why they are called as cold bodies. Whenever a hot body and cold body, they are placed in contact with each other, there is a flow of the internal energy from the hot body to the cold body, and this flow of the heat energy which is flowing from hot to the cold body, we call this as the heat energy. So what actually is the heat energy? Heat energy is actually that energy which is flowing from hot to the cold body. So the energy lost by the hot body and which is in the process of moving towards the cold body, we call it as the heat energy. Once this heat energy is gained by the cold body, some part of this heat energy absorbed by the cold body, it will increase the state of the random motion, that is the kinetic energy, and some part of it will increase the potential energy, because kinetic and potential energy are together, their sum total is known as the internal energy. So when heat energy will be absorbed by the cold body, it will become or appear as the internal energy of that cold body, because energy is absorbed by the body. So due to this absorption of the internal energy, there will be a rise in the temperature of the body. So thus, how can we define the heat energy? This is the accepted definition which we have to use also for the exams. Heat energy, it is the sum total of kinetic energy and potential energy of all the molecules of a body. So heat energy is the sum of the kinetic energy and potential energy of all the molecules of a body. Units of the heat energy. Conventional unit of the heat energy, older unit of the heat energy is 1 calorie, which we already know is equal to 4.182 joule, or rounding it off, it is equal to 4.2 joule. How do we define it? 1 calorie is the amount of heat energy required to raise the temperature of 1 gram of pure water by 1 degree Celsius. Mind you, pure water is essential. So 1 calorie is the amount of heat energy which is required to raise the temperature of 1 gram of pure water by 1 degree Celsius. But this definition is not completely correct. Reason, this definition is suffering from an important problem associated with the use of pure water, that is the problem of anomalous expansion. So water suffers or have the problem of anomalous expansion. This definition requires that if we are increasing the temperature of water, suppose from 10 degrees Celsius to the 11 degrees Celsius, from 21 degrees Celsius to the 22 degrees Celsius, or suppose from 45 degrees Celsius to the 46 degrees Celsius. So in all the three cases, there is an increase in the 1 degree Celsius temperature of the water. So if there is increase of 1 degree Celsius temperature in all the three cases, then the amount of heat energy required to raise temperature from 10 to 11 should be same as that of required from 21 to 22, and it should be also same equal to when the temperature increases from 45 to 46 degrees Celsius. But actually this is not. Reason, because water has the property of anomalous expansion. So amount of heat energy required to raise the temperature from 10 to 11 degrees Celsius is not equal to 21 to 22 degrees Celsius and from 45 to 46 degrees Celsius. So this definition of the conventional unit of the heat energy is not accepted. So what is the correct definition? We will take a look at that in the next video. Thank you.